Welcome back, everyone. It's my pleasure to introduce our next speakers, Ariana Mendible and Manuchehr Aminian. Ariana is currently an assistant professor of mathematics at Seattle University. Her engineering background focused on developing data-driven methods to improve reduced order models for fluid systems with underlying symmetry. Dr. Manuchehr Aminian, also known as Manuch, is an assistant professor in the Department of Math and Statistics at California State Polytechnic University, Pomona. Manuchehr's research interests include early detection of viral infection with machine learning, mathematical methods in data science, and passive tracer problems. Manuchehr and Ariana currently serve as the co-directors for QSIDE Small Town Police Accountability Research Lab. Ariana and Manuchehr, thank you for joining us, and please go ahead with your presentation.
Thank you so much. Good. Here we are. I'll trust you and tell me if you can't see it. On the contrary. Thank you for having us. I'll point out our third co-director is Anna Hinch. I think she's talking later today as well. So equally important in making all this happen and keeping us moving. I think it's been a joint effort between all of us to really make this a continued successful lab, as we'll see. Okay, so what I'm going to intend to do is talk about our beginnings and some of the things we do, and it might be of interest for the audience to hear about some of the details of how the lab works, as well as talking about some of our research directions. Okay, so who is involved in SToPA? So by the way, the acronym SToPA is Small Town Police Accountability Research Lab, affiliated with QSIDE. We give a snapshot of the people involved here. I can rattle off names, some are in the audience. Spencer Brooks, Anna Hinch, Eric Amezquita, that's Ariana Mendible, Micah Henson, myself, Alex Wiedemann. Good. We are represented across the entire country, basically. Many of us are at various universities, as you can see on the left-hand side. Yeah, West Coast, East Coast, middle, you name it. Our pre-lab experiences are all over the place as well. Mathematics is probably overrepresented, right? But you can get an idea. So for those in the audience that might feel like, oh, I don't do this, I'm not trained in this. To some degree, that's okay, right? I mean, you go in cautiously and you be humble and get input from others who have more expertise than yourself. But just because it's not something you've been doing since you were born doesn't mean you can't get into it. Of course, data science, computer science, engineering also represented as well. So to some degree, we have some variety of perspectives coming in. Okay, so to give you an idea of why Williamstown and what is the point of all this, what sparked this, we need to focus on the Williamstown Police Department in particular. Williamstown itself is a small college town, as I would describe it. I'm not from there myself. I collaborate. I work with the QSIDE folks. As you might know, Chad Topaz teaches at Williams College, which is in Williamstown itself. Small population, majority white, right? They have their own police department and governance. There's a few activist communities there as well involved that we've been communicating with on and off. They have been in the news over the past few years for various very problematic things. So we will go ahead and say, Williamstown Police Department, what gives? They've been called out both locally as well as picked up by more major news outlets to show that this is not really like a one-off thing. They have a history of officers being very problematic, glorifying Hitler, for instance, or you know, you name it. It's an ongoing problem, so it's not as if one person got in trouble and got fired and that's the end of it. And so activists in town are essentially really wanting to understand what's going on. Who can we talk to? Are there certain groups more problematic than others, blah, 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 right? So there's 1,000 questions you can ask and directions for analysis you might take. Okay, so there's a large story in between, but the very short version of this is that Chad, along with some students of his at Williams College, essentially did an extended process of trying to get a Freedom of Information Act request, trying to get police records over several years. So that was a bit of a battle, as I understand. I'm happy to talk about it after our main talk. But the end result was a couple of years of scanned police records, which we get to look at in detail in a few slides. Yeah, and the pitch of the Datathon for Justice, which is another QSIDE sponsored activity, which happened some months back, was essentially here are the logs scanned. Go for it, right? Do what you can. So Chad didn't exactly say, here it is, do your best, but that was more or less the pitch, which is exciting in a way. In a sense, the lack of direction means that people are more excited to approach this from ways that may not be expected from the get-go, right? Some degree of creativity is involved. The Datathon for Justice itself was not exclusively focused on this. Its theme was criminal justice. And so there were about 6 or 7 groups, if I'm remembering right, who opted to focus on one thing or another. Ariana and Anna were the co-leaders of one of these groups who chose to focus on this, and hence why they continued on as co-leaders of this research lab. There was a Michigan State University team involved as well, who were in person working together in a room. Understandably, if they have the numbers to do it, then I don't blame them. For myself, I got excited in this when I saw how successful they were with their early processing of this data that we're going to see in a minute. As you can see, the main challenges for this specific data set during the Datathon were essentially try to digitize these records in some fashion and try to follow up with any kind of analysis in any direction you might think of. Now, what is the anatomy of one of these logs? You will forgive me for my fantastic pun, if I do say so myself. What are they? Okay, so moving on. Sorry, right? Not that kind of log either. What are these logs looking like? This is really what it is. Okay, so when I say 3,800 pages or so, this is what it really looks like. They essentially got enormous boxes of pages delivered to their front door after this very long fight. Some poor student, which I will leave unnamed, had the task of hand scanning these. So these are not like clean PDF files where everything, all the words are showing up nicely and everything is tabularized. This is a very zoomed out version of 3 of these pages, for instance. You can see there's occasionally redactions. That was done by the police department, to my understanding. There are certainly plenty of names and identification numbers, specific dates and times, but this format is not like a CSV file. It's not a JSON file, one of these standard data types, which you might be familiar with if you've done a data science course. A little more zoomed in, just to give you a slightly closer view. That's one of those pages. I have opted to remove some of the personally identifying information here of the person involved. So if you look on the right here, this is log 1994, and the officer involved is listed here. In this case, this had to do with the vehicle, so they listed the make and the model and the color, and owner. Potentially there's race and gender information involved as well. Okay, but these go on, and there's 1,000 complications. So at this point, I'm going to pause and let Ariana take over. I'll trust her to tell me next slide, and she can tell us about some of the details since she's more intimately familiar.
You can go to, or do you want me to take over this one? So there's a lot of complications with this data. The first one being that all of this, rather than being like highlightable text like you would really want in a data set, everything's just a photo. So the first step that we had to do in the Datathon was to do optical character recognition, which, if you're unfamiliar with that, which I totally was when we started this work, it's basically taking individual kind of like pixels of your picture and looking for patterns in it so that you can pull out characters and words. And so there's a number of kind of like prepackaged, either open source or paid software that you can use to do this. But the one that we chose to use was Google's Tesseract, which was kind of the easiest off the shelf to kind of like get running. And you go ahead and you parse all these logs, and what it's doing is it's scanning and using kind of like neural networks to figure out what all this text is. There's a lot of complications in that though, because the structure of the text is not necessarily obvious. In the call logs, we have kind of like keys where we have, you know, location, address, or officer name and things like that. And then everything else in a different column, which is not really how you would expect to read like a word of page, like a normal document, like a book. So getting all of this into like a nice structure is a huge task. So during the Datathon, we were able to go ahead and parse all of that into like pretty good call logs. But you can see here's like an example of what we did. And when you get all this information out, there's a number of misspellings. This, I think, was already corrected text. And so a lot of this, we just still have a lot of issues in the data. And in general, if we're doing this with kind of like just for fun data, that's totally fine. But really what we want to focus on in this work is getting reliable, correct information, because if we're misreading all of these different things, if we have incorrect times or incorrect names or anything like that, we can't make claims. And kind of our ultimate goal of what we want to do is investigate patterns within the data and to be able to say with some certainty that this is happening to real people's lives. So this is super important that we can actually correct these and get, you know, reliable data out of our original data. So we have all of these call logs. Another complication is getting it into like a usable format. What we would really like is this big, you know, either pandas data frame, if you're familiar, or just like an Excel spreadsheet that has for every call log all of this information. And this is a lot harder than it seems just because of the ordering of the text and kind of the structuring of everything. But ultimately, during the Datathon, we were able to get a decent amount of really good data that was at least good enough to be able to do some investigation, some preliminary investigations with. So here's just an example. We have things like the call number, which is just kind of like each instance of a police interaction with people or any type of data that they're writing down, who was interacting with the person or writing stuff down, and kind of all these different data types, like the location or why they were doing it, what the outcome of the call was, and also some information in narrative format that might be like some notes about a car accident or like a correspondence between two neighbors or something like that. So all this data is super unstructured and kind of, there's lots of different types of information we can be taking out. So here's kind of just an example of what we would get. So with that data, we were able to do a couple of things. One of them that I primarily worked on was mapping some incidents, like each call log that happened in a certain year or a certain time frame. And this is actually an interactive map that's not easy to show on a PowerPoint, but basically this weird like square is a map of Williamstown. And what we did is we were able to go ahead and parse the written addresses into actual GPS locations and plot them, all these call logs over the town map. And there's all kinds of interesting ways we could kind of segment the data and look at it, but I chose to group by which officer was kind of initiating the call. And so you can see on our like histogram, you can actually cross filter and select individual officers and kind of like highlight only their actions and locations, or choose multiple and then hover over and we can see any amount of information we want. This is just an example of kind of the ones that I chose to show, but we can, you know, highlight anything out of that. So this was just one outcome. Manuchehr worked on this during the Datathon a little bit, kind of looking at what are the temporal patterns of police calls. So is there any kind of information that we can glean from the frequency that they're interacting with people, or are there times where they're kind of not as active and more active, and how does that maybe correlate with kind of world events? So you can see here that he's plotted the Massachusetts stay-at-home order, which makes sense. The frequency of police calls over time goes down. Like obviously everyone was staying at home, maybe people were a little bit uncertain, maybe officers weren't going into work as much. So we have decreased activity. And then after the George Floyd murder, we see a little bit more increased activity. Maybe they were responding to protests, maybe there was other things going on. So it is really interesting to be looking at this type of information, and ultimately this is the direction that we want to be going in, is being able to see patterns within the data that we can correlate with real world events or with external factors. And there's infinitely many possibilities. This is just one example. So because we got so much done just in the Datathon and it was so exciting, I think we got a lot more done than we anticipated. It seems like we could get so much more done if we continued on, that it shouldn't just be left at that. So one of the research labs that came out of the Datathon was ours. And we decided to kind of incorporate the work that we had done before and also build on that, add more people, and build it out into a real kind of machine that we can keep working on. So a little bit about like who we are, how we do it. Generally, everyone's kind of all around the country, like we already said. So we just have Zoom meetings, and I would really like to be able to meet eventually in person at some point, and we can talk about that. We have some things in the works. But we have, a shared GitHub. If you're not familiar with GitHub, this is just like a way that everyone can share code and work together. The majority of us are kind of data science mathematicians. So we often talk about our code and are able to cross-reference and kind of update each other on that easily. We have meetings where we get together, talk about our goals, talk about what we've done. And we also have kind of working sessions that are pretty informal, and we just use it as a dedicated time to work together or work separately on our same shared goals. I think these are really useful because there's a lot of different kind of interdisciplinary people that can talk and share expertise. And I think it's really invaluable to get to know what everyone's working on and kind of learn a little bit about each little area of our research lab. So me, Manuch, and Anna all together lead all these meetings and kind of facilitate communication. Okay, so what have we actually done so far? So based off of the original data, I kind of highlighted a number of things that were issues, like common issues in the data, mostly misspellings and kind of like incorrect structure. And so the way we've chosen to attack that is to improve using user input information. So the first thing I want to talk about is kind of like domain specific names and words and patterns. So if we have call logs and we know it's from a specific town, especially a small town, we know that there's only going to be a certain amount of officer names. It'd be pretty easy to get a file, go on, the Williamstown Police Department website and figure out all the names and copy and paste them into a file and use that as an input for the OCR to kind of match that as well as possible. So built into pretty much any OCR, there's a dictionary of any words that it's looking for. And really what we want to do is just expand that, because normal, English words don't include Eichhammer or specific street names, for example, like Hoosac. And we don't want to always let that get misspelled or be turned into a like normal word that's in an English dictionary. We also want to be able to include certain patterns that we're looking for. So especially in terms of like the call number or times and things like that, we know that we're looking for a pattern of arrived, ARVD, and then the time in 6 digits with colons, like a normal time. So including these in the library of what we're searching for improves the text parsing a lot. Like we can read things much more accurately. That I've been working on that along with Micah. Eric has been working on kind of cleaning up everything that is still misspelled. So as we can see, we have all of these misspellings on the left-hand column on the bottom there. We have every possible misspelling of Michael Streezy. And what we need to do is just identify that those are actually all the same person, and we can just correct that spelling in post. So Eric has been working on doing fuzzy matching to kind of transfer all these names and correct them. We also need to be able to detect the structure of the text. So like I said before, kind of really complicated to actually read in all of this information. It's so obvious to our eye because we just read left to right and it makes sense. But in terms of kind of parsing this into the correct structure that we want so that it says call taker and then the person's name is actually quite complex, because it's just as easy to say this is a 2-column data set. So getting that to be parsed correctly has been a task that Mike and I are working on together, and we've made good headway on. And the last thing is kind of blacklisting characters. So there are certain things we're going to use, maybe like US dollar signs and question marks and things like that. But realistically, I don't think that in the Williamstown police data, there should be too many like pounds or TM or like copyright symbols. So just automatically getting rid of those and saying don't include those in our data set can also improve how we're reading it out. So the next kind of thing that a group has been working on, specifically Alex and Spencer, have made a lot of headway in this, and Anna is also working on kind of her own version that I am super interested in learning more about, is topic modeling. So what we want to do ultimately is be able to have kind of like a hands-off look at all of our data, not having to say, I want to look at this specific instance and that specific instance, or these relationships to each other, but kind of learning from the data, what is it telling us, what like patterns and what topics are in there that are important. So in that direction, they have been working on kind of automatically identifying topics that are important in the data using natural language processing and some kind of low rank embeddings. And they have some really interesting results where you can kind of learn, you put in all the call logs and it says, oh, I know that there's like certain call logs that always say like vehicle and smoke and intersection. So these are probably about a car crash. And you can cross filter and automatically learn from the data rather than searching for the word car, what's happening and what kind of patterns are emerging. So this is really helpful just to kind of figure out what's going on in your data, but it also can be really useful if we're trying to build kind of a reusable toolkit. So the ultimate goal of what we're working on is to just have some kind of like either Python code or long-term something that anyone could just upload data to without any kind of expert knowledge and be able to learn about their own police call logs. So if we have something like this where in an unsupervised way we can identify topics, it's going to be really helpful for kind of anyone at any level to be able to learn, including like activist groups, social scientists, things like that, where you can very quickly kind of like figure out what's going on in your data without having to search it on your own. Another direction that we're going kind of in this vein of looking at like the relationships within the data more at kind of the expert level is looking at kind of more statistical mathematical models or kind of like spatial mapping and seeing if there's some way that we can build out these relationships. And just looking at kind of like base level, if we pick, you know, specific topics that we want to search for, looking at patterns in space and time, looking at, you know, distribution. Are there areas that are over policed? Are there areas that at a certain time have had like a suspicious number of calls? Who is doing what? These kinds of questions are really interesting to investigate. Just from our own perspective, you know, knowing like what's going on in Williamstown, a little bit more about the history and background, investigating those in a data-driven way is another goal that we're working on.
So I will jump in and take over this point, if you don't mind. Following up on topics, right? This third aspect has some overlap with the others, but I think specifically thinking about interfacing with local activists, the kinds of questions that are asked are not easy, essentially, to handle with very black box things that you might be familiar with. Even if you take an introductory data science course, right? Often the kinds of things you're doing are like, find all the rows which match a pattern. So for instance, you could say, as we saw in the previous slide, like find all the call logs associated with a specific officer. Or like find all the call logs associated with one specific address. That's often not what people are asking, right? They're often interested in neighborhoods or regions. So of interest to anyone at Williams College would be, what are the police logs looking like near the college, right? Where students are living, where faculty are living. So describing all logs within 3 blocks of Williams College is a more abstract thing to ask and more challenging to address from a programming perspective. So for instance, right? Or maybe you have a major thoroughfare, you know, a major street where there's a lot of restaurants or shops or where people gather. I mean, notably, especially when you're working with activists, neighborhoods where people will tell you like, there is a serious issue here. There's over policing or abuse is happening. It's not as if we're saying this is this county or you know, a rectangular block, like block 1 to block 2, block A to block B. You really need the tools to be developed so that essentially you can sit down together, you pull out a map and you can say, I essentially associate this neighborhood with where the issues are. even though it's not something I can look up in an official US Census tract or anything that you might formally understand that way. This is what really needs to happen if you're going to make progress. Also included in this slide, especially I think Alex is interested in this, is the direction of developing the tools in the direction for teaching. So getting students involved in this way and recognizing that these data science tools go beyond simply the sort of starter data sets you may be familiar with. So if iris sounds familiar to you, like identifying these 3 types of flowers, or the more popular one nowadays is the penguin data set, trying to distinguish 3 types of penguins based on measurements. It's a fun way to start, but students kind of roll their eyes in a similar way that like, okay, this is fun, but I don't really see how this is relevant to the real world, or this doesn't feel very substantial. Developing these tools so that you can get students appreciating that they have more agency in the skills they're developing is very important. I think that's something that we're looking into as well. Okay, so I think that gave us, I hope I gave you all, and Ariana gave you all a cool picture into what we're doing and the things that we're hoping to do. We have many dreams. Some of them are very broad, maybe too broad. What I wanted to put in for the last couple slides is conversation starters. Some of these might head off questions you already have, and I'm really interested to see what people say. But this is also questions that I think we have for you all. Would be interesting to get input from people as well. One of these, which I alluded to at the very beginning, is that basically most of our team are mathematicians or recovering mathematicians, as we sometimes joke. What gives? I mean, the very short answer is that this is QSIDE established. Chad Topaz, one of the co-directors of the lab, is a mathematician. So through his professional network, it's essentially easiest to communicate to other mathematicians. But I don't think that's the whole story, really. The pandemic is part of the issue, probably. So we're kind of constrained in the ways that we can try to network and cross boundaries. I think QSIDE has done a lot with more than essentially any other mathematician that I know, especially even excuse me, losing my words, interdisciplinary ones that I know. And I know many interdisciplinary scientists. But even with that, I feel like there's a lot of friction in expanding and maintaining a truly interdisciplinary or multidisciplinary team. Some of these are not things that have easy fixes, but again, I'm interested to hear any input. There's expectation differences, especially when you're working with junior academic people in different disciplines. Like, what does a grad student do? What kind of free time do they have? Is funding involved? Are there expectations for career development that are different in math compared to social sciences and then other things, you name it? Challenges in communication is a classic thing, jargon that's used. Yeah, maintaining engagement. Oh, so what I mean by this one, I think I put this bullet point down in particular, was suppose we are in a coding heavy aspect and we're trying to collaborate with someone who's not a coder. What do you do? Among others. Generalizability is of course another major region for questions, which you might ask, well, what happens if we want to achieve our long-term goal of a toolkit that works for any town? What happens when the logs look different? So I don't have a good answer to this other than to start looking at it. And that's something we are starting to do right now.